Let us understand what are sign diagrams with the help of few examples. Our focus is on quadratic inequalities, which we are going to take up in the next video. Here, we like to understand how do we use the sign diagram, and that can help us to solve inequalities. What is a sign diagram? Let's say we have a polynomial function. Let's say this is the polynomial function for us, which has some x-intercepts. Let's say these are the x-intercepts. That's the y-axis. In that case, you're going to notice that these are the intercepts. Now, you can see that the function is continuous and it is negative in some portions, positive in some, right? So the intervals are defined by the x-intercepts. Between each interval of x-intercept, the function remains either positive or negative, right? So we can say, let's put some values here. Let's say this is -4, this is -1, and this is, let's say, 3 for us. In that case, when is this function less than 0, or when is the sign negative? So we can say that for this particular function, y equals to f of x is less than 0 in these intervals from -infinity to -4, correct? And then from -1 to 3. Similarly, we can say that the function is greater than 0 between the intervals from -4 to -1 and beyond 3, right? Infinity is the other end. So 3 x-intercepts divide the graph of the polynomial in 4 intervals. Testing any point will tell us whether that interval corresponds to function being of negative sign or of positive sign, correct? So that is how we are going to answer the question. So first step will be to find the x-intercepts and then to test in each interval whether the value is positive or negative. So let's start with solving questions one by one. Here is the first one, which is x squared plus 2x minus 15. Now you need to factor to find the x-intercepts. 15 minus is the product, and we can take 5 times 3, so it could be written as x plus 5 times x minus 3. So where are the zeros? Zeros means x-intercepts in this case will be at x equal to -5 and at 3. Sign diagram really means on a number line, here is a number line, we'll plot the zeros. Let's say this is -5 for us, right? Here we have a 0. And on the right side, we have 3. Now, in each interval, we should take some points. Convenient points to figure out whether the value of the function is positive or negative, correct? So, we call them as the test points, right? Let me use a different ink to write down these test points. So, let's say we have these test points. So, in each interval, we have a test point. Let's say this is -6. Here, we could take 0 as such a test point and 4 on the other side. Now, if I plug in -6 here, then what happens? See, we get -6 plus 5 times -6 minus 3, right? So, what we get here is a -1. So, negative times -9, right? So, when you multiply two negatives, we get positive. And therefore, in this interval, it is positive. You get the idea. Now, if I substitute 0, it is very easy. It is you can use the quadratic equation given to you. It is minus 15, and you find this is minus. And if I substitute 4 in this, you'll find that it is again positive. Let's check it out. So 4 plus 5 times 4 minus 3. So 4 plus 5 is 9, and 4 minus 3 is plus 1. So we do get a positive sign, correct? So you see that the graph in this particular case will be positive in the interval 0, minus infinity to minus 5, negative between minus 5 to 3, and positive after 3, right? So that is how we make a sign diagram. So this becomes the sign diagram for us. I hope it makes sense, right? With this concept, let's move forward and take up more questions. Now here we have a factored form, right? So you don't have to factor in this case, but understand the concept now. So once again, when you have a factored form, you see on a number line, mark the x-intercepts or zeros. The zeros for this is at 0 and at 2. So here we have a 0 and here we have another 0, right? Now you need to test points, correct? So let me write down test points in the lower column. So test points will be, let's say, minus 1, 1, and 3. Plug in the values, right? So 3 times minus 1, minus 1, minus 2, correct? So we get minus 3 times minus 3, which is positive, right? Which is greater than 0. So we can write positive here. You get the whole idea. Now, you also notice that all are linear zeros, right? So, concept here is that if you have a linear zero, in that case, it is different sign on the opposite sides of the 0. So here it should be negative and then positive. So sometimes you do not even have to test. So linear 0 means alternating sign. You get the whole idea. So as we move along, we are also learning fast ways of doing it. Of course, you can plug in a value and check for yourself. You get the whole idea, right? So that is how you could actually quickly sketch the sign graph. Let's take the next example, which is minus 2x plus 3 whole square. Now in this case, you see minus 2x plus 3 whole square should be always less than or equal to 0. Because this negative 2 is negative, right? And x plus 3 whole square will always be positive. So here we have x-intercept at x equals to minus 3, correct? So when you draw a number line, let's say we have a number line here. We have only one 0 here. I'm just marking 0 as a reference frame. 0 is at minus 3. So we have a 0 at minus 3. So we need to test only two sides of this, right? On left and on the right hand side. So on the left side, let's take a value which is minus 4. On the right side, let's take 0. Now if I substitute minus 4, what do I get? 2 times minus 4 plus 3 whole square, which is minus 2 times, this is minus 1 whole square, which is positive 1 multiplied with negative 2, only minus 2. Do you see it is negative, right? So in this side, it is negative. On the right hand side, if I plug in 0 here, I get minus 2 times 0 plus 3 whole square, which is minus 2 times 9, and again a negative number. So here also, on this side, also we have negative, right? Sorry. So both sides will be negative. So what we learn here, that if we have an even degree 0, in that case, same sign on either side. So, these things, they really help you to find quick answers, correct? Let's move on and take up the next question. Now, here, the question is very interesting. We are given x plus 5 times x square minus 1. Now, x square minus 1 can be factored, right? So, it can be written as equal to x plus 5 times x plus 1 times x minus 1. So, we have three zeros, and all the three zeros are linear zeros, right? So, we have three linear zeros. That means alternating sign. So this really helps because we need not test each and every interval, correct? Let's mark the zeros here. The zeros are at x equals to minus 5, x equals to minus 1, and x equals to 1. So let's say this is our minus 5. This is minus 1. Here we're just writing 0. And on the right side we have 1. So we have four intervals. Now let's take a test point. A good test point will be 0 itself. So if I plug in 0, what do I get? I get 0 plus 5 times 0 square minus 1, right? So we get 5 times minus 1, correct? Now 5 times minus 1 is negative 5. So in this interval, we get a negative value. So that means in the other interval to the right side of this should be positive, here also positive, and it will be negative on this side. You get the whole idea. So we have made a sign diagram just by checking one value, knowing the concept that linear zeros will have alternating sign. Hope that makes difference. So this is a great strategy to answer the questions in less than a minute, in just few seconds. Now here is another example which I like you to pause the video at this stage, answer, and then draw the sign diagram. Well, in case you want to learn directly from me, feel free to send an email on globalmapinstitute@gmail.com. Our students are right there on the top, getting excellent marks and admission to the best universities. Now, look here. Where are the zeros? Well, we have only one real zero, right? So I should really write x-intercept, not the zero, right? Because there are other complex zeros. So x-intercept is at x equals to minus half. So here, let's say this is our reference frame, and we have a 0 at minus half. So we can test any one particular point, correct? So on the right side, we have 0. So if I plug in 0 here, what do I get? I get 0 plus 1 times 0 plus 1. So we get positive 1, right? So that means in this case, on the right hand side, we have positive sign. Since the 0 is linear, right, it will change. You get the whole idea. So what we here get is negative on the left side of minus 5. You get the whole thing, right? Minus half. So again, linear 0 will mean alternate sign. And what we did, we just checked one value, which was 0, on the right hand side. This value gave us a positive result. And therefore, we know the right hand side is positive, left has to be negative. And that's how we draw a sign diagram. You get the whole idea, right? Now, this concept is going to help us to solve inequalities. Here is the last question. Here we have a cubic factor and also something to factor. So the question here is very interesting. We have x plus 8 whole cube, and this is x squared minus 4. Now x plus 8, we have a cubic 0, right? So, but x squared minus 4 can be factored. So let's rewrite this as x plus 8 whole cube. And this will be x plus 2 times x minus 2, correct? So we have zeros or x-intercepts at x equals 2 minus 8. But see, the degree is 3. Let me write this multiplicity or degree. And here we have at minus 2, which is 1 linear, and here we had 2 a linear, right? So when I draw a number line and mark the zeros, So let's say the reference frame is right here as 0, right? So we have minus 8, plus 2, minus 2, and plus 2. Correct. Now we need to figure out whether which interval is negative, which is positive. Now, cubic is like linear. You get the whole idea, right? So let's check this value, 0 itself, which is within the interval minus 2 to 2. So if I plug in 0, what do I get? If I plug in 0, I get 0 plus 8 whole cube times 0 minus 4. Now, 8 cube is positive and this is negative, and therefore we get something which is less than 0. We don't really need the value. We need to know whether it is positive or negative. So here we get a negative sign. Now these are linear zeros and therefore the sign will alternate. So we have positive here and positive here. Now cubic is like linear. You get the idea. So here also it is going to change. You get the whole idea. If you sketch a graph, it will look something like this. Let me also sketch and show you. Since it is degree 5, right? So here cubic means the graph will go like this. Do you understand? And then on these zeros, it will go turn like this. So that is going to be the graph of the polynomial. So with that, we have sketched the polynomial to show you how the sign diagram really helps us to figure out where the graph of the function is negative or positive. I hope it makes sense. And this is going to help us in solving inequalities questions, which is our next video. So I'd like you to understand the concept and take up these inequalities to solve. I hope you find it interesting and useful. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.